We are looking at the exercise 19.16 of chapter 19 r.d.sharma solution, class 12th. We have sec square x by 1 minus tan square x. Now we know that the differentiation of tan x is directly sec square x. So if we place t equals to tan x, this differentiation dt by dx will give you sec square x, which is the numerator also. The dt will become sec square x dx, which can entirely be replaced if you take t as tan x. Numerator we can write like this now after the replacement or assumption. This will be dt. The denominator will become 1 square minus t square because t was taken as tan square or tan theta. This dx by a square minus a square, this integration you already know. It's 1 by 2a log of a plus x divided by a minus x, and this has to be contained inside the modulus. Please remember, in a square minus x square, a plus x will come in the numerator. So a is 1 here and x is t in this case. So let's use the formula 1 by 2a, a is 1, log a plus x by a minus x. So 1 plus t by 1 minus t, this modulus sign, plus constant of integration. So the final thing which is remaining is, let's replace now by t equals to tan x because t was introduced by ourselves. 1 plus tan x divided by 1 minus tan x. And let's close the modulus plus constant of integration. This is your final answer. So this is how it has to be done. E raise x by 1 plus e raise 2x. First thing is integration of e raise x or differentiation of e raise x will be e to the power x only. So when we take t equals to ex, the dt will be equals to e raise x dx. dt will be e raise x dx. So this whole numerator, which is dt. So let's write this dt. In the denominator 1 plus e raise 2x. When you square e raise x, it will be e raise 2x. So t square it will be. Denominator will become 1 square plus t square. So it's equivalent to tan inverse x. Because when we differentiate tx by a square plus x square, where a is equal to 1, it will be tan inverse x. You will see how. If it is a square plus x square, it will be 1 by a tan inverse x by a. 1 by a tan inverse x by a. So let's write it 1 by a tan inverse x by a plus c. This whole you have to use. Please remember a is 1 in this case and x, if you refer to the formula, x will be equal to t. So when we integrate this, this will be tan inverse 1 by 1 tan inverse t by 1, which is eventually tan inverse t by t plus c. And t was taken as e raise x. So tan inverse e raise x plus constant of integration. So this is how it needs to be done. E raise x equals to t. This remember please. Cos x divided by sin square x plus 4 sin x plus 5. Now we know that sin x will directly give you cos x. So when we place t equals to sin x, dt by dx will be cos x dx. So this dt can be replaced by cos x dx directly. This whole in the numerator. So let us write it as dt. Integration will be something like this. Dt divided by sin square x will be t square. Plus 4 into sin x. What is sin x t? So 4t it will be plus 5. Now this t square plus 4t plus 5, we can convert it into the perfect square. So t square plus 4t plus 5. Now whatever is the coefficient of t, which is 4, just make it half. So it will be 2. Then square it, that will be 4. Add this and subtract this. So t square plus 4t plus 4 will give you t plus 2 whole square. That is the perfect square now. And the remaining terms are 5 and 4. 5 minus 4 is 1. So it will be 1 square. So this integration will become like this. Integration of a dt divided by t plus 2 whole square plus 1 square. Now t plus 2, if you take this as p, dp by dt will be equal to 1. That is dp will be equal to dt. So dp, if at all we assume it to be p, but you don't have to because dp is coming as dt. If there is some change, then you can just do that. This t plus 2 at some p. We know that integration of 1 by x square plus a square is simply 1 by a tan inverse x by a. Now use this formula here also. Take x as t plus 2 and take a as 1. So in this formula when we use it, it will be 1 by a 1 by 1 tan inverse x by a, that is t plus 2 by 1. Eventually it will be tan inverse t plus 2 only. What was t? It was sin x. So tan inverse 2 plus sin x is your final result with a constant of integration. So this is how we have to go about it. Don't forget to write this let and now and all the English kind things so that the examiner can understand what you are trying to do. And wherever there are certain formula being used, just on the right hand side, make a box and write the formula also. Now e raised x divided by e raised 2x plus 5 e raised x plus 6. Now e raised x, the differentiation and integration of e raised x will always be e raised x only. So we can get the e raised x dx in the numerator whenever we put t equals to e raised x. So dt by dx will be equal to e raised x. The dt will be equal to e raised x dx. That you already know. So this integration will become like this. The whole numerator is going to be dt if we assume t equals to e raised x. Let t equals to e raised x. That's what we do in the initial part. Now when we square it, e raised 2x, it will be t square. So that's why e raised 2x can be replaced by t square plus 5 into t plus 6. We'll try to make this as a perfect square now. What is the easiest way of making a perfect square? Just write the expression or a quadratic equation. Take the coefficient of t, which is 5 by 2. Square it. That has to be added and subtracted to the original expression. When you square, add and subtract, this t square plus 5 by 2 whole square plus 5t is t plus 5 by 2 whole square. That has become a perfect square. Now we are left with the constant term, which is 6 minus 5 by 2 whole square. That is 5 by 2 is 25 by 4. So 6 4 is 24 minus 25 divided by 4, that is negative 1 by 4. This can be written as negative 1 by 2 whole square because 1 by 2 whole square is 1 by 4 only. Now this integration will become 1 by integration 1 by x square minus a square, which is 1 by 2 a log x minus a by x plus a. Please remember, this t plus 5 by 2, if we put it as some p, the differentiation will be same. dt will be equal to dp. So don't worry about putting this t equals to t plus 5 by 2 equals to some other term in order to get rid of t plus 5 by 2 and making it as a simple one variable. Because when you differentiate it, it is going to come similar. So now you have to assume x as t plus 5 by 2 and a as half. So 1 by 2a, which is 1 by 2 into half, and then log x minus a. I told you x, we will take it as a t plus 5 by 2. So t plus 5 by 2 minus half in the numerator, and the denominator it will be t plus 5 by 2 plus half. And this 5 by 2 minus half can be resolved further. That will be 5 by 2 minus 1 by 2 is 4 by 2, that is 2. So the numerator will become t plus 2, the denominator will become 5 plus 1 is 6, 6 by 2 is 3. So t plus 3 it will be. So t plus 2 divided by t plus 3. Now before doing this, why can't we just chain t equals to e raised x? If you remember, t was e raised x. So that will be our final substitution. That was the first thing which we took when we started this question. So 1 by 2a, which is 2 gets cancelled, log e raised x plus 2 divided by e raised x plus 3 plus constant of integration. That will be your final answer. So this is how we are going to go about it. This is the reference solution for you if you want to do it by yourself. This is an important question you should remember in your mind. This may come. Now e raised 3x, e raised 6x. So e raised 6x is the square of e raised 3x. E raised 3x is the cube of e raised x. You already know that. I'm just showing it to you just to recall because we are going to employ it in just a while. E raised 3x can be taken as t, assumed to be t. When you differentiate this t, dt by dx will give you e raised 3x. The differentiation of 3x will be 3. So 3 into e raised 3x will come. So e raised 3x, if you want to find it out with a dx, it will be dt by 3. So dt by 3 will be e raised 3x into dx. Now this whole e raised 3x dx will be dt by 3. So integration will be like this. E raised 3x dx will be dt by 3. So 1 by 3 comes here. 4 into e raised 6x will give you 4 into, now we have to square e raised 3x in order to get e raised 6x. So it will be t square. So 4t square minus 9 will be, now this 4t square minus 9 can be written again as a square form. 4t square can be 2t square and 9 is of course the square of 3. So can we use it directly? See, if you can put 2t equals to something, okay, but you don't have to do it. I'll just show you. Even if you put 2t equals to something p, then the result will remain the same. I'll show you here. You know dt by x square minus a square is what? 1 by 2a. You already know the formula we have done in the previous question. 1 by 2 into a is 3 here, x is 2t here. Log, and this will be log modulus inside. So 2t minus 3 will come in the numerator and 2t plus 3 will come in the denominator. Now we'll not stop here because we are dealing with 2t. So 2t minus 3 will be differentiated. Please remember, hold this 2t minus 3 and 2 will come. That 2 has to be divided. So 2t was to be, see, if you would have taken 2t equals to p, this dp by 2 would have come. That is why 2 is there. So there are two ways to do it. Either you just use this formula and then differentiate 2t minus 3 and divide it, which will come as 1 by 2, that you already know. But the other thing is 2t equals to p can be taken. So this is all 2. Basically, I'm explaining why 2 has come in the denominator. Other things you already know. So this 3 into 2 into 3 into 2 will give you 1 by 36 log 2t, t in place of t we can write it as e raised 3x, 2 e raised 3x minus 3, 2 e raised 3x plus 3 plus constant of integration. That will be your final result. So this is the way, okay, the whole step I have already explained you that you can just go about it. This e raised 3x, let now all this has to be written without failing to write the symbols and all mathematical notations. Now first we will resolve this, and then once we resolve, then we can apply the same scheme which we have just applied in the previous question. That is, this denominator, if you take e raised x plus 1 by e raised x, because e raised minus x is 1 by e raised x. So when we cross multiply and take the LCM, e raised 2x plus 1 divided by e raised x, and this whole is 1 by, please remember I was talking about the denominator. So when it goes up, when we actually write it, this e raised x will be in the numerator, 1 plus e raised 2x will be in the denominator. So this e raised x, because it's simply 1 by 1 plus e raised 2x divided by e raised x divided by 1. So this is the whole scenario. These are the whole 1 by 1 steps, and this will go up e raised x dx, and denominator you have e raised 2x plus 1. Just take e raised x equals to t. When we differentiate this, dt by dx will be e raised x, so dt will be e raised x 2x. E raised 2x we have got in the numerator, this will be dt. 1 plus e raised 2x will be what? T square. So it is 1 square plus t square. A square plus x square, 1 by a, tan inverse x by a. A is 1, so don't worry about a. It will be 1 by a, 1 by 1, tan inverse t by 1. So you can just write it as tan inverse t plus constant of integration. But t was taken as e raised x. Let's replace it here now. Tan inverse e raised x plus constant of integration is your final answer. How we need to do it? It's just resolving e raised x plus e raised minus x by x raised 4 plus 2x square plus 3. Now you know already that x square differentiation will give you x, and x square is x raised 4. So we are getting into a formulation of quadratic equation. When we take t equals to x square, this dt by dx will be equal to 2x, dt by 2 will be equal to x dx. So the numerator x dx will be dt by 2. So integration will become this dt by 2, x dx will be dt by 2. Let's take dt here, by 2 will take place here. X raised 4, this is x square whole square, that is t square plus this 2t plus 3. Now in order to make this as a perfect square, because this is not a perfect square right now, so we have to take it as a perfect square. Let's resolve it. What we need to do, please recall that when you write this one, just take the coefficient of the middle term, which is the x term or t term. It's 2. Divide it by 2, that is going to give you 1. Now square it, 1 square is 1 only. Now add this 1 or that square and subtract that square, which is 1 minus 1. So what we got? T square plus 2t plus 1 plus 2. Now this whole one will be t plus 1 whole square. And this 2 has to be squared. How can we square it? If you put a root on it and square it, it will be 2. Because 2 raised half into 2 will be 2 gets cancelled. So it's root 2 into whole square. So the integration will be, finally, we can write this term as, because x dx is a dt and there was dt by 2 also, if you remember. So t plus 1 whole square plus root 2. What is integration of x square plus a square? It's 1 by a tan inverse x by a. That's the standard result. Now x will take it as t plus 1. A will take it as root 2. So 1 by a tan inverse x by a is root 2. So 1 by root 2 tan inverse, and please remember this it was dt by 2. So I'm just engaging this 2 here, and tan inverse x by a. So it will be 2 plus t plus 2 divided by t plus 1 actually. So t plus 1 divided by under root 2. Please remember t was x square. So x square plus 1 divided by under root 2. So let me just change this t equal to x square and x square plus 1 by root 2 plus constant of integration. That's your final result. So this is the reference for you. You can just follow this reference and please write the formula wherever it is applicable so that the examiner know you know the formula, and making it a perfect square is always known to you from the previous classes. X raised 5, x raised 6, 12. So the first observation says that x raised 5 will come from the differentiation of x raised 6. And the denominator x raised 12 is x raised 6 whole square. So x raised 6 whole square is nothing but x raised 12, which is the 2 gets multiplied by 6. So we'll take x raised 6 as a t so that we can get this x raised 5. So I'm writing what is given in the question. This 3 you can deal later. Now t equals to x raised 6 will give you dt by dx. This will be 6x square, x to the power 5, because nx to the power n minus 1 is the formula we have just employed. Now from here to here, it's dt by 6. You don't need to keep 6 along with x raised 5 dx because you're replacing x raised 5 dx, which will come as dt by 6. Now dt by 6 is there, 3 was already outside, 6 is in the denominator, 3 and 6 gets cancelled, you get a half. This is half. Now 1 plus x to the power 12, which is 1 plus t to the power square, which is x12 is x6 to the power square. x6 was taken as t, so 1 plus t square. Now you already know in the previous question we have done 1 by tan inverse x by a, which is the standard result. So 1 by 1 plus x square, you can directly write it as tan inverse x. Why? Because if you write 1 by a tan inverse x by a is what? It's 1 only. So tan inverse x. So 1 by 2 tan inverse, this is t plus constant of integration. What is t here? X raised 6. So 1 by 2 tan inverse t, which is tan inverse. I forgot to write tan inverse, okay? Just remember tan inverse is there. So I just forgot to write that tan inverse. Please remember that is there. You can see that in the reference solution also. This question we'll take in the next discussion. Till then, thank you so much and have a good one.